All right, this video is over topic 30, number 1A through E, looking at scatter plot. So a scatter plot has X and Y values that go together. Each pair of X and Y corresponds to a particular, in this case, building. It could be a particular day, particular year, but there's something connecting those to make that particular X go with that particular Y. And one thing you'll need to do is sketch a scatter plot. This will be analogous. You'll just be clicking at the point. It doesn't have to be exact, but roughly in the right place. So as I'm looking at these, the X is the horizontal, the Y is the vertical. So 485, 40, I find there's 450, 500, so somewhere in between there, and then 40 between the 36 and 42. So somewhere in there. And 511, 37. 520, 41, 535, 42, then 582, 38, somewhere in here, 615, 45, over here, 616, 31, way down here, and then 635, 40. Those are farther over than they should be, but as long as it's still in the right square, again, not going to be a huge problem. 728.54 up here, and 841.64 here. So there's a scatter plot, and what we're looking for is patterns in that, especially if there's a linear pattern. And although that left end didn't really have much of a pattern to it, once we added those last 2 points, you start to see more of a linear pattern. For B, we're going to look at having Excel do this process because outside of class, that's going to be the easiest way to get a scatter plot rather than doing it by hand. So I'm going to put my heights in one column, stories in the next column. And then as long as my cursor, my active cell is somewhere within that table, Excel will recognize when I go insert and I choose the scatter plot option here, it will, as you can see, select the whole table. And I can do all sorts of things to make this look nicer. I can change the title here and say this is building versus number stories. I can go here and add axis titles, so then I can put in the um, in feet, and I can put in double clicking on these to edit them, number of stories. And then notice there's a lot of white space on this graph compared to what we have here. So I can adjust because these are starting at 0 rather than at 350 on the horizontal and 24 on the vertical. So I can change that. I can click on just where these numbers are, right click there, and go Format Chart Area. You can also access that through the plus here. It would be data label. Well, axes probably more options. When I did this and got that, let me go for my axis. But sometimes it'll come up and it will have things collapsed or it will be on the wrong tab here. So you want to look for the graph tab, maybe to open things, but I can make this graph start at 350. I'll get to count by 50 instead of 100. And that will make it look more like the graph we started with. And then I can do the same thing. Just come over here and click on the number of stories. It'll switch to that axis. I'm going to make that go from 2466, counting 6. And so we get the graph looking more like what I plotted here. Of course, the points are plotted more precisely than what I was able to do by hand, but it looks fairly similar. Then what we will want to look at with these is what's called a line of best fit. So I can sketch an approximation of what I think the pattern is looking like, the sort of closest straight line I can get. So if you look at it, let's say, if I do something like this, you can see like that's definitely not. So um, again, this isn't something that has to be exact as you're doing this in Alex, but try and get as, something that seems reasonable. It doesn't want to get me with it. So there it's still, you want it to basically be balanced on either side as far as the number of points or how spread out they are. So a point farther away has more effect than a point closer. Maybe I move this down. Maybe I get a line that's even, get a line here that's going through like 4 of these points. That seems fairly balanced. It doesn't have to go through any points though. Um, so I can do that by hand, kind of eyeball it, but the actual line of best fit isn't a subjective opinion thing. There are calculations that can be done with each of those data values. So 10 buildings, 20 data values with the height and the stories of each, all put into a calculation to find the M, and all put into a calculation to find the B for the y equals mx plus b linear equation for the line of best fit. So Excel has already done that. I just have to get it to show me that. So I click trend line here. I did my plus. You can do chart design, add chart element. Also is another way to get to those. And so it's put in the trend line, and you can see it's actually a little bit lower and less steep than what I had drawn here. So it was more affected by, they were affected differently by some of these points than what I was visually expecting. So I'm going to take off my line now so that it's not in the way. And we can see this line of best fit. So if I'm looking at this trend line, it can be used to estimate, it can be used to predict. It doesn't guarantee anything. It doesn't override the data to say, like, this is what's happening when we look at actual buildings that, like, that's not what happened. But if I want to predict the number of stories for a 675-foot building, that would be here halfway between the 600 and 700. Find where that hits, and it's right about here on this line at 48. So we would predict 48 stories. Now we can also get the actual equation for this line of best fit. So if I right click on the line, or if I and go format trend line, or here go to trend line, get the arrow, more options, different ways to get again to this format panel. Again, if things are collapsed, might need to do some clicking to get there, but looking for here where it says display equation on chart. Let me get this. All right, so you can move this around. You can change the size, whatever you want to do with that, but that's the equation. So y equals 0.0685x plus 1.6463. So now I can use the equation to calculate the number of stories for a 675-foot building. It is going to get me a much more precise answer than just looking at the graph. It should be the same, like the graph and the equation represent the exact same thing. They're two representations of that relation. So when I plug into the equation, I should get something close to 48. If not, I've made a mistake. It is going to, again, be more precise, but that doesn't make it more accurate or more correct or more guaranteed of a prediction. It's just more precise. So I'm plugging in 675 is the x. So 0.0685 times 675 plus 1.6463. And so I calculate that. And I get 47.8838. If I rounded that to a whole number, as we would with a number of stories, it's still going to come out 48. But we see the line that is actually slightly below 48 there. All right. So we're going to let's go ahead and finish number one here. So as building heights, we're looking at correlation. As building heights increase, the number of stories tends to increase also. Now, we didn't see that on the left side. We had taller buildings with fewer stories and quite a few of those, but the overall trend with that line moving up to the right is that they tend to increase. And when both things increase together, so as the height increases, the number of stories increase, that's what we call positive correlation. Important thing to note is that positive and negative are both equally, there is correlation. So there's is correlation or there's no correlation. Once there is correlation, that correlation can be described as either positive or negative. Negative does not mean the same thing as no correlation. It doesn't mean that it's weaker correlation. It is equally correlation. It is just the direction of it. So, as far as strength of correlation, that has to do with how close those points come to forming a straight line. The more spread out and scattered the points are, the weaker the correlation. So here we have several points that are pretty scattered and spread out from the line here, others that are close. I would probably not call this strong correlation. Probably, I don't know, somewhere in the range of weak to moderate. So the points are somewhat spread out. You can also kind of think of this as like a margin of error that however far above and below the trend line you have to go to get to the points becomes kind of a margin of error. So this line, instead of just a line, is like this wider thing. So, like for the 48, I'm saying, well, the line is at 48, but it could really be quite a distance above or below that. Now, as with the line of best fit, the correlation strength can be calculated using all of the data values, both x and y, from the data points to find something called the correlation coefficient, or what we'll be looking at, the r squared value, which is just the square of the correlation coefficient, and they work pretty similar. Um, the r squared value is a number between 0 and 1, with 0 being no correlation, 1 being perfect correlation, and then sort of the range in between. It works more like a percentage, like a letter grade, as far as it's not like um, equally divided, weak, moderate, strong. It's more like anything 50, 60 or below is probably considered weak. Get into the 60, 70 range, moderate, 80, 90, strong. So I'm going to go to my trend line format panel again here and check the display r squared value. And there it is. So it is 0.637. And that would be 63.7%. So that'd be like a D grade again, sort of corresponding, like maybe getting towards moderate, but still on the weak side. All right. So let's see what happens if we change some of these points, because all of this again is based on every single one of these data points. I'm going to move, that's going to get rid of all of these. All right. Okay, so I'm going to get rid of those two tallest buildings. Those are the ones that really established our pattern there. So if I take those out, so I'm just selecting the cells with those data values, hitting delete, and you see we get a very different looking pattern here. Now it's actually trending slightly downward. It's very weak. It's now 0.0152. So 0.0152 would be 1.52%. That would be a very low F. If somebody's getting that kind of grade, they really have not been doing almost any of the work. That would be very weak. Um, you could probably really just say there's no correlation, but technically there's a tiny bit. The new equation is now negative 0.009x plus 44.298. So it's again now a negative slope. It's a smaller slope, but the size of the slope, like the steepness of the line, doesn't necessarily correspond to the strength of the correlation. The negative means that it's now negative rather than positive. Um, so yeah, it is now trending slightly downward and very weak. All right, so now I'm going to go back in and undo. So just do a little Control Z here. Back. All right. So I have those points back. Now I'm going to look at what happens if I take away the sort of most outlier building, which would be this one here. So this is the 616. If I hover over it, it'll tell me maybe. Yeah, 616.31. So if I take that one out, and so the line, let's see that made the line go up a little bit. Now it matches more of those points. It didn't change the slope a lot. It was 0.06, 0.0685. Now it's 0.0697. So it's gotten a tiny bit steeper. It's moved up a little bit. But the biggest change there is in that R squared value. So it is now 0.8329, which would be an 83.29%. So now we're definitely into the territory of like a strong correlation. Not like super strong, but a fairly strong. So the direction is pretty similar, slightly steeper, but still positive. Um, Correlation is now strong. All right. So that's number one, just kind of exploring what you could do in Excel with scatter plots and trend lines, the strength of the correlation, and so on.